Welcome to another math problem of the week. To 6-digit number, change position. Let's talk about it. For today's question, let ABCDEF and EFABCD be two 6-digit numbers such that 4 times ABCDEF equals to EFABCD. And we want to know how many such 6-digit number ABCDEF. And the options are A1, B2, C3, and D4. What do you think?
Pause the video now if you wish to solve it. Keep watching the video once ready.
For some reason, whenever this question asks, I always think of a special number, that is 7. Because 1 over 7 is equal to 0.142857, 142857, 142857, and the pattern repeats. As such, we can just write as 0.142857 with dot in 1 and 7. It means that this block of 6 number will keep repeating. And we'll see that 2 over 7, then it will be start from 2, then followed by 85714. And for 3 over 7, it is 0. Started from 4, then 28571. If it's a 4, then it is 0.571428 and keep repeating. And for 5 over 7, it is 0.714285. And finally, 6 over 7, it is 0.857142. Then from this list, then we see that 1 over 7 is 0.142857. And 4 over 7 is 0.571428, and it is 4 times of this previous number. Then we can further verify that 4 times 142857 will equals to 571428. And it means that one of the possible ABCDEF is equals to 142857. However, this may just only one of the many other possible value of ABCDEF. We need to find out a systematical way to get all of them. And we'll see that whether it has any relation with a fraction with other denominators. So let's look at a proper way of doing this question. The standard way of doing this question, that is, we'll let x to be a 4-digit number ABCD and y equals to 2-digit number EF. From this relation, it is 100x plus y. And from this, 10,000y plus x. So after expand this will be a 400x minus x. That is 399x. And from this is 10,000y minus 4y. So it is 9996y. And we can check that both of these two numbers, 399 and 9996, has a common factor of 21. And therefore, 19x 476y. So it means that in this case, xy will be equal to 476k and y will equal to 19k for some integer k. Since 476k has to be a 4-digit number, it must be at least 1,000. So means that k has to be at least 3. And also 19k must be less than 100. It must be a 2-digit number. And it means that k has to be less than or equals to 5. So with this, then we know that k can be either equal to 3, 4, or 5. And now let us check what happens when k equals 3, 4, and 5 respectively. If k equals to 3, then xy 1, 4, 2, 8 and 5, 7. When k equals to 4, xy will equals to 1, 9, 0, 4, 7, 6. Finally, when k equals to 5, xy will equals to 2, 3, 8, 0, 9, 5. And we can check that all of them satisfy the condition. And therefore, the answer for this case is equals to C. If you enjoyed this video, please like, comment and subscribe. As mentioned, we shall look at what is the relation of all these answers. And that's interesting to find out that they all related to the fraction with the denominator 21. That is, 3 over 21 is equal to 0.142857 with a block of this 6 digit keep repeating. And 4 over 21 is equal to 0.190476 with the block of the 6 digit keep repeating. And finally, 5 over 21 is equal to 0.238095 with the block of the 6 digit keep repeating. And we can find out that the fraction 12 over 21, 16 over 21 and 20 over 21 are as such. And therefore, all the answers related to the fraction with the denominator 21. In fact, you found out that this kind of relation always occurs whenever similar question was asked. And for now, let's look at other people's solutions. That's all for today's lesson. I'll see you again next Tuesday. Bye bye.